All right, boys and girls, welcome. Today we're going to do section 9.3. And in section 9.3, we're going to be solving rational equations, okay? So we're going to start off with example 1, and we're going to do A. And basically what they want us to do for this part is they just want us to solve each rational equation algebraically, okay? So here they gave us 3x plus 7 over x minus 5 equals 5x plus 10 over 2x minus 10. Okay, so there's a couple of things you need to know. We're going to treat these like fractions, okay? So think of all the properties of fractions. Think of adding and subtracting, okay? When you add and subtract fractions, what are you supposed to have before you can even add and subtract fractions? Think about that. Okay, so hopefully you remember that when adding and subtracting fractions, you should be finding common denominators, okay? So think of the top values. In this case, we have some binomials, some terms. Those are your numerators, and then your bottom is your denominators, okay? So we always have to have common denominators, okay? In this section, we're going to be introduced to something called extraneous solution. Basically, these are going to be your excluded values, okay? Think about this. Okay, let me move this up. Something called extraneous, and this is how you spell it, okay? Extraneous solutions. Just think of it as kind of like excluded values. These are values that we're not going to include, okay? So one thing you should know about fractions is you can never have in the denominator, your denominator should never ever be equal to 0, okay? Why? Because if you put any, and you can try that if you have a calculator, put any number over 0 and your calculator will say error, okay? Now if the 0's on top, that's a different story, but you should never have 0 in the bottom. So in order for us to get our extraneous solutions, and by the way, I say solutions, but it could be solution, it could be one or more. What you're going to do is you're going to set your current denominators equal to 0, okay? So here's what we're going to do. We're going to write x minus 5 equals 0 and 2x minus 10 equal to 0, okay? So set your current denominators equal to 0, and this will help us solve for our extraneous solution. And again, the reason why we're setting them equal to 0 is because the bottom, your denominators, should never be a value of 0, okay? So here we're just going to solve for x. So we're going to add 5 to both sides, okay? And then we're going to end up with x equals 5. So for the first one, x can never be 5, which makes sense because if x was 5, then we would have 5 minus 5, which equals to 0, okay? So if we somehow end up with a solution of 5, then it would be an extraneous solution, which means we don't include it, okay? So it would be excluded. And in this one, in order for us to solve for x, we would add 10 to both sides, and then we would end up with 2x equals 10, and then of course divide by 2. And then we would end up with x equals 5. So notice it's the same, okay? So same thing here. If we were to make x 5, we would get 2 times 5, which is 10. 10 minus 10 is 0. So again, looks like we only have one value, okay? Our extraneous solution can never be 5, okay? X should never be 5, okay? So that would be our excluded value. Okay, now before we start solving, here's the next part. Ready? Now what we're going to do is we're going to treat this like a regular fraction problem. So the next part that we're going to do is we're going to find the LCD, okay? The least common denominator, okay? So I'm going to move this up just a little bit just so that we can concentrate on that. So that's kind of the second part, okay? So for the second part, find the LCD, okay? Least common denominator. So we just want to concentrate on x minus 5 and 2x minus 10, okay? And then the way you find your least common denominator, remember, is basically you cannot add or subtract fractions until they're exactly the same, okay? So in the first denominator, we have x minus 5. In the second one, we have 2x minus 10. If you notice, this one's completely factored. There's something we can factor out. But in this one, we can factor out a 2. So we're going to factor out a 2. And then we're left with x minus 5. So one thing you're going to notice is both of them have x minus 5. But what this denominator has that this denominator doesn't have is a 2. So we always want to take the least common denominator. So our LCD will actually be 2x minus 5. It's the product, okay? So our LCD would be 2 times x minus 5. This is our LCD, okay? So just think about it this way. If something has, if there's a denominator that has more than the other one, then that's the one we want to include. And if there's something here that this one doesn't have, we want to include it in both, okay? So this is our LCD, 2 times x minus 5, okay? All right, so now we're going to bring that into solving it. So let's get started. Okay, here we go. I took the liberty to rewriting the equation again, and I wrote it in a different whiteboard. So we still have our other whiteboard. So we have 3x plus 7 over x minus 5 equals 5x plus 17 over 2x minus 10. So we're not adding these fractions or we're not subtracting them, but notice they're equal to each other. So what we're going to do is I'm actually going to rewrite these. What I'm going to do is I'm going to subtract this fraction and move it to the left-hand side. So what I'm going to have now is, ready? I'm going to have 3x plus 7 over x minus 5. And I'm going to say minus, and then I'm going to put it in parentheses. I'm going to write 5x plus 17 over 2x minus 10 equals to 0. Okay. Sorry, that marker doesn't seem to be the best. There we go. Okay, so now I want to just show you all I did. All I did was take this fraction that's on the right-hand side of the equal sign and subtracted the entire fraction so I can move it to the left-hand side so that now it's equal to 0, okay? Now, it doesn't always have to be equal to 0. You'll see in some of the examples. But in this one, since we weren't adding or subtracting, I turned it into a subtraction, okay? All right, so now we have 3x plus 7 minus all of this, which is 5x plus 17 over 2x minus 10. Okay, so now here's what we're going to do. Remember the LCD. The LCD that we had earlier was 2 times the quantity of x minus 5. So now what I'm going to do is I'm going to multiply it to each of the fractions. So I'm going to take 2 and x minus 5 and multiply it to this fraction. And I'm going to do the same thing over here. And I'm actually going to move the 0 just a little bit. So times 2x minus 5 and set it equal to 0, right? Again, I'm only multiplying the LCD by the fraction. LCD by the fraction. I just had to move the 0 a little bit, okay? Now, this was our LCD. Now, here's what's going to happen, okay? X minus 5 and this x minus 5 should cancel out, okay? And so basically, we'll just have a 1 here, okay? And so what would happen is when they cancel out, or they should reduce in a way, is that we're only left with 2. So what we're going to have is, ready? We're going to have 2 times 3x plus 17, okay? And then now on this side, 2 times the quantity of x minus 5. Remember, when we factor this out, this is exactly the same. So 2 times the quantity of x minus 5 is the same as 2x minus 10, except this is factored out. So what's going to happen is the entire denominator is going to go away, okay, and all of this. So we're just going to get 1. So then what we should have left, ready, is minus, and I'm still going to keep this in parentheses, 5x plus 17 equals 0. Okay, so now we have an equation instead of 2 fractions, okay? So the whole point of multiplying by the LCD is to get rid of your denominators. So that's kind of a heads up, okay? So if they don't go away, then you did something wrong, okay? So now that we have this, let's start applying some properties. The first thing we're going to do is distribute this 2. Okay, so now we're going to end up with 6x plus 14. And then the next thing we're going to do is see how we have this minus here. Let's go ahead and distribute that minus. So now we're going to end up with negative 5x plus, oops, not plus, minus 17, okay, equals to 0, okay? All right, so ready? Now our goal is to solve for x, and now we're going to start simplifying it some more. So 6x minus 5x, those are like terms, so 6x minus 5x would just give me x. And then 14 minus 17, that'll give me negative 3 equals 0. So look at that. We simplified all this, and so now we have with the linear equation. So there's just one more step. Add 3. Okay, so our final answer should be x equals 3. Okay, which is really nice. And I'm going to show you again just what we did this. We solved this one from beginning to end. Okay, and I'll explain it one more time what we did. But now that you solve for x, what that means is x is our solution. Since x is not an excluded value, we can say x equals 3 is our only solution. Okay, and that's it. So I want to remind you what we did. So I'm going to go over this. Feel free to pause the video at any time so you can copy. Again, they set these two fractions equal to each other, but what I wanted to do is rewrite them so that we're subtracting it. So then we set it equal to 0. Then we found the LCD and multiplied each fraction by the LCD, which basically got rid of the denominators. And then we rewrote to this 2 times 3x plus 7 minus 5x plus 17. And then I went ahead and distribute the 2 and distribute the negative. Combine like terms. Added the 3 to both sides, and then ended up with x equals 3. Now, kind of a heads up, if we would have ended up with 2 solutions, which by the way, sometimes you can end up with 2 solutions. If we would have ended up with x equals 3 and x equals 5, we wouldn't have included x equals 5 anyways, because that was an excluded solution, okay? So this is our only solution. All right, awesome. Okay, so this is just one example. Let's do another one, okay? All right, boys and girls, now we're moving on to the next example. So our next example is 2x minus 9 over x minus 7 plus x over 2 equals 5 over x minus 7, okay? Okay, so notice this time we're going to be adding fractions, and they gave us a third one, so it's not equal to 0, okay? So as always, I'm going to tell you guys to always, for the first part, always find your extraneous solution, okay? Always. Start with this part first, extraneous solution. And again, I'm going to put solutions because it could be more than one, okay? So the way that you find your extraneous solutions is simply set your denominators equal to 0. So notice we have x minus 7 here, but we also have it here. You don't have to set them both equal to 0 because they're exactly the same. So we're just going to set one of them. And then notice you have here what we call a constant, just a number by itself. If you set that equal to 0, you're not solving for x. Notice it's just a number, and 2 will never be 0. So here's kind of a heads up. Whenever you have a constant, don't even bother setting it equal to 0 because that'll never happen, okay? So only set your denominators that actually contain an x, okay? So there's only one in this case. So obviously if we add 7 to both sides, we're going to end up with x equals 7. So this is our only excluded value, okay? So somehow at the end of this, if we solve for it and we end up with x equals 7, then we won't include the solution, okay? So step 1, always look for your extraneous solution, okay? Then step 2, let's find that LCD, okay? Okay, so remember what I said, LCD, you want to concentrate on the denominators. There's 3, but 2 of them are the same, so let's only look at one of them, okay? So notice we have x minus 7, oops, I put it as a comma, sorry. We have x minus 7 and 2. They are completely different, okay? So notice this is a binomial, we have x minus 7, this is a constant, we have 2. So since they're different, basically this is missing a 2, and this is missing x minus 7. So when they're completely different like that, then your LCD, I meant to write it a little bit different, then your LCD is just a product of both. So you can write it as 2 times x minus 7. And this is your LCD, okay? Again, it's a product of both. Kind of like we did earlier with 2x minus 10. Remember, one of them had x minus 5. The other one had 2 times x minus 5. So we want to make sure they're exactly the same. So our LCD is 2 times x minus 7. Okay, so these are the two things you have to do before you start solving. All right, here we go. Now we're actually going to solve it. So let's move on. Okay, so now if I want to solve for this, the first thing I have to do right away is multiply by the LCD to every single fraction. Okay, here we go. So we're going to multiply 2 times the quantity of x minus 7 to the first fraction. And I'm not going to do that yet. Let me just set it up first. Second fraction, same thing, 2 times x minus 7. And then the third fraction, 2 times x minus 7. Okay? Now, if you remember, the whole purpose is to get rid of your denominators. Okay, so look at your denominators. Here we have x minus 7. Here we have x minus 7. So the whole thing will cancel out. They just reduce to 1. Here we have a 2. Here we have a 2. So those 2's will cancel out. X minus and x minus 7 will cancel out. Okay? And I write the 1's on purpose because people think that it's 0 and they just go away. It's not 0, it's that they cancel out to 1, okay? And 2 times 1 will just give you 2. And anything over 1 will just give you itself, okay? So now I'm going to rewrite this. Don't forget we have a 2 here, so it'll be 2 times 2x minus 9. Again, I'm just rewriting it. I'm not skipping any steps. Plus x times x minus 7 equals 5 times 2. Okay, so I just wrote down everything that we have left over. Okay, here we go. And so now I'm going to move this up now. Okay, so now the next part is to start distributing. So we're going to distribute a 2 here. And over here, we're going to distribute the x. Okay, so now we're left with 2 times 2, which is 4x. 2 times negative 9, which is negative 18. Plus x times x is x squared. X times negative 7, negative 7x. And 5 times 2, which is 10. Okay, awesome. All right, so now we're going to combine like terms. So we can combine 4x and negative 7. And that'll give us negative 3x. But notice a couple things. Notice we have a quadratic and a constant. What you should notice is that you're going to end up with a quadratic, okay? A trinomial. So let's write them in order. So what I'm going to do is I'm going to write x squared negative 3x minus 18 equals 10. Okay? Okay, now I'm going to clean this up some more. So remember, the only thing is I combined like terms, and that's how I got negative 3x, and then I also wrote them in order. But notice you have it set equal to 10. Go ahead and subtract that because we have another term like it right here. Okay, so now we're going to end up with x squared minus 3x minus 28 equals 0. So this should look very familiar because you're solving for x just like you did earlier, but now you have a quadratic trinomial. And one of the methods that I've taught you guys to solve for quadratic trinomials is to basically factor. So I want to remind you, ready? You're looking for two factors that multiply to give you negative 28, but add to give you negative 3. Can you think of what they are? Again, multiply to give you negative 28, but add to give you negative 3. So, ready? Hopefully you tried it in your head or wrote it down. You should have x minus 7 and x plus 4. So these are the factors. And again, set it equal to 0. Okay? So you're going to factor that out. And once you factor that out, then remember, just use the zero product property. Set each one of these equal to 0 and solve for x. So here we go. I kind of ran out of room there, so I'm going to do it on this side. So x minus 7 equals 0, which many of you could do mental math. So you end up with x equals 7. And then x plus 4 equals 0. And then x equals negative 4. So those are our two solutions. Now notice that in this case, we did have an extraneous solution, and our extraneous solution was x equals 7. What that means is if 7 is one of our solutions, we can include it. We cannot. So notice x equals 7 is an extraneous solution, so we cannot include x equals 7. So therefore, our only solution would be negative 4. Okay? So, ready? I'm going to write this on the side. X equals 7 is extraneous. I'm running out of room, but if you guys have been in a math class before, 3 dots like this means therefore, okay? Therefore, x equals -4 is the only solution. Okay? So let me go up, and you guys can either pause the video to copy or, you know, just kind of watch and write it down as you go. Okay, so remember, the first thing we did earlier was find the extraneous solution, LCD. Always go in that order, okay? And then what we did is we took our fraction and multiplied by the LCD, and that got rid of all our denominators, so we ended up with this equation. But then we distribute it, and it looks like we distribute to every single term. Then we combined like terms and wrote it in the right order, quadratic. Then we subtracted 10 to set it equal to 0. We factored out the quadratic, and we ended up with 2 solutions, but 7 ended up being extraneous. So we only included -4. Okay? All right, awesome. I have one more for you guys to do. All right, boys and girls, here we go. Here's the last one that I'm going to do with you. So we have 8 over x plus 3 equals x plus 1 over x plus 6, okay? Once again, the first thing you should do is check for your extraneous solutions, okay? All right, so here we go. Look at your denominators, and they're both different. So set each one of those equal to 0 and solve for each one, okay? You could almost do mental math, I'm sure. So the first one, x equals -3, and the second one, x equals -6. So remember, you cannot have these values as your final answers, okay? And then the second step we're going to do is find our LCD, okay? So notice we have x plus 3 and x plus 6. They are completely different, okay? Completely different. Right? And remember, this is a binomial, so they're together. There's a combo deal, okay? So I've heard people say in the past, well, oh, there's a 3. This has a 3. Nope. It's x plus 3. They're together. So since they're both completely different, then your LCD is a product of both. So basically your LCD would be x plus 3 times x plus 6. This is your LCD right here, okay? It's a product. So whenever they're different, you just multiply this. Simple as that, okay? This is your LCD, okay? And remember, it's a binomial, so it's like together. Okay, so now we're going to work on solving this, okay? So let me grab my second whiteboard. Again, you can always pause the video and copy this down. Okay, so here's our problem. 8 over x plus 3 equals x plus 1 and x over x plus 6. If you recall, this is very similar to the very first one I gave you, where they were equal to each other, and I basically rewrote them as a subtraction. So again, I'm going to do the same thing. So I'm going to write 8 over x plus 3, and I'm going to subtract our fraction. And so I'm going to have x plus 1 over x plus 6 and set it equal to 0, okay? Because subtracting all of this is moving it to the left-hand side, and so now you're ending up with 0, okay? Okay, so once I do that, and by the way, I only have to do this when their fractions equal to 0, when they're not already adding and subtracting, okay? And then the next thing that I'm going to do, if you recall, we're going to multiply by the LCD. So in this case, the LCD was a product of both denominators. So I'm going to do that. Okay. By the way, in the second example, you notice I actually did it to all 3. Well, I don't have to do it to 0 because anything times 0 is just going to be 0. Plus, there's no denominator here. So there's no purpose on doing it here, okay? So we're just going to do it here. So in the first fraction, what's going to simplify is the x plus 3. In the second fraction, what's going to simplify is your x plus 6. Okay, so now what we're going to have left is, ready, 8, oops, that's not a good marker. Let me grab a different marker. Is we're going to have 8 times x plus 6 minus, and then put it in parentheses, guys, x plus 1 times x plus 3. Okay, Okay, then ready? Distribute the 8. And then over here, what we have to do is we have to do FOIL, okay? So, and by the way, equals to 0, okay? So, we're going to distribute the 8. So, this is going to be 8x plus 48. And over here, I'm going to ignore the subtraction for now, okay? And I'm just going to do FOIL. So, x times x is x squared. X times 3 is 3x. 1 times x is 1x. And 1 times 3 is 3. Okay? And then combine like terms. Those are looking like division signs because my marker's running out. So let me grab another marker. Okay, so I'm going to combine like terms right here. So now I have x squared plus 4x plus 3. And then don't forget I have this minus. So now what I'm going to do is I'm actually going to distribute to everything. Okay, so here we go. Ready? I'm going to have 8x plus 48 minus x squared minus 4x minus 3 equals to 0. Okay. Okay, so this is what I have left. Okay, so now what we're going to do is we're going to combine like terms. So 8x and negative 4x are like terms. 48 minus 3 are like terms. Okay, so I'm running out of room here, so let me grab my second whiteboard. Okay, so now I'm just going to clean this up, okay? And I'm going to write it in order. So I'm going to write negative x squared, and then 8x minus 4x, that's going to give us positive 4x. And then 48 minus 3 is going to give me positive 45 equals 0, okay? Just cleaning that up a bit, okay? So once again, you're going to notice we have a trinomial and it's quadratic. So now we're going to factor out. Here's the deal though. Usually we never factor out when your x squared is negative. So all I'm going to do, ready, is, okay, I guess what would be a different way of telling you to make it simple? Suppose I moved everything to the right hand side. All it would do is flip the signs, right? So if I move negative x squared to the right side, it'd be now positive x squared. If I moved 4x to the right side, it'd be negative 4x, and 45 to the right side, it would be negative 45. So these are equivalent equations. So believe it or not, I can actually rewrite this as x squared minus 4x minus 45 equals 0. These are exactly the same. They're equivalent, okay? Or it's kind of like dividing by negative 1, if that makes sense. Okay, so I'm going to be using these. Okay, if that confused you in any way, let me know, but it's very simple. Okay, just think of it as I moved everything to the right hand side. Okay, so a quadratic equation. So remember, we solve quadratic equations using the AC method. So again, we're going to factor. So think about this. Ready? Can you think of two numbers that multiply to give you negative 45 but add to give you negative 4? Okay, hopefully you came up with x minus 9 and x plus 5. Negative 9 times 5 gives you negative 45, and negative 9 plus 5 will give you negative 4, okay? And now we could just apply the zero product property. So where I said each one of these equal to 0. So each factor equal to 0. Oops, too soon. Okay, and then if I solve for each one, I should end up with x equals 9. And x equals negative 5. Okay, so we end up with two solutions. And if you recall earlier, our excluded values were negative 3 and negative 6, negative 3 and negative 6, which either one is an excluded value. So what that means is both of these are solutions. Okay, so the solutions are x equals 9 and x equals negative 5. These are both solutions, okay? All right, boys and girls, awesome. So I gave you 3 examples, so I think that's more than enough to try some on your own. So let me give you 2.